Reading straight line graphs. Well, all straight line graphs have to have two key points we need to know about the graph. And they are, we need to know the gradient, which is how steep the line is, which means for every one across, how many squares up or down do we go. And the second thing we need to know is the y-intercept, so where it crosses the y-axis. And once we know those two key values, we can put it into this equation. Y equals mx plus c, where m is the gradient and c is the y-intercept. And it's either going to be plus or minus depending on whether it crosses on the positive y part or the negative y part. So, y equals mx plus c. So how do we go about finding the gradient? Now, the gradient is found by looking at, for every square across, how many do you go up? So what we need to do is we need to find a point where our line crosses one of the proper coordinates. We go across one square and then up to where it meets again, the line again. And if we count, that is 2 squares. So that means this has got a gradient of 2. So it's m is 2. The gradient is 2. The second thing we need to know is where does it cross the y-axis. So if we look along the line, it crosses here at -6. So the c is -6. Now we know those two values, we can put them into the equation y equals mx plus c. So where this m is, we're going to put our gradient, which is 2. And where the c is, rather than putting 6, we're going to put -6 because it crosses at -6. So we need to find those two key points. So we need to find the gradient and the y-intercept. So for this one, we need to find the gradient and we need to find the y-intercept. So where does our line cross the y-axis? Well, it actually crosses here, which is 0. So the y-intercept is 0, but we need to find the gradient. So for every one across, how far do we go up? So for one across, we go 3 squares up. So the gradient is 3. So y equals the gradient, which is 3x plus c. Well, the c is 0, so we put plus 0, but we don't need to put plus 0 because it has no effect. So it's just y equals 3x. So far, we found the gradient by looking for one square across, how far do we go up, and also where does it cross the y-axis, because that is our y-intercept. Now this graph here, you should notice, is going downhill rather than uphill. Now this time, if we look to find the gradient, so we pick a point where it crosses, so there, and go across one square. This time, rather than going up, we're going to go down. And we go down 3 squares. Now because we have to go down, it means it's a negative gradient, so it's -3. And where does it cross the y-axis? Well, we need to go down our line. Where does it cross? Here, which is -3. So the y-intercept is -3. So in our equation y equals mx plus c, we can replace our m and our c by our gradient is -3, and instead of having plus, we're going to have -3 because that's where it crosses the y-axis. So we need to find the gradient. So for every one across, how far do you go up for a positive gradient or down for a negative gradient? Also, we need to know the y-intercept, which is where our line crosses through the y-axis. And once we know that, we can put it into the form at the very top here, y equals mx plus c, which is the standard way of writing any straight line graph. Now, if you were asked to write down the equation of a parallel line to this, well, a parallel line to this, remember parallel means it's got to never touch. So it's going to go something along the lines of this, where they're never going to touch. Now, if they're never going to touch, it means that their gradients must be the same. So y equals the gradient was 2, so it must be still 2x. And then we can pick any point up the y-axis, provided we don't pick the minus 6 that it already goes through. So we could pick plus 2, like I've drawn on my diagram. So if you're asked to write down a parallel line, it means that the gradients must be the same, it's just the c-intercept changes.